You click play on a video. 1 second later, a server somewhere on the internet starts sending data back to your laptop. It feels instant. It feels simple. But your laptop did not magically know where to go. Behind the scenes, a small team of network devices helped that request travel from your screen, across the local network, out to the internet, and back again. Today, we are meeting that team. Pause and predict. Which device helps your laptop leave the local network? The answer is usually the router, acting as the default gateway. If that sounded new, perfect. By the end of this video, it will feel normal. In this episode, you will learn what clients, servers, switches, routers, firewalls, and wireless access points actually do. We will also quickly name two CCNA bonus terms, controllers and PoE, or Power over Ethernet. Not in a memorized definition way. In an I can look at a network diagram and explain what is happening way. This matters for the CCNA, but it also matters because every Wi-Fi problem, every slow game connection, and every why can I not reach this website question starts with these basics. Here is the whole path. Do not memorize it yet. Just notice that each device has a job. Let's start with the easiest pair, clients and servers. A client asks for something. A server provides it. Your laptop asks for a video. Your phone asks for a website. Your game console asks for a match server. Those are clients. The machine or service that sends back the video, website, file, or game data is the server. So if your phone opens your school portal, the phone is the client, and the school portal is hosted on a server. Quick check. If a laptop downloads a file from a website, which device is the client? The laptop. The client is the one asking. Now let's zoom into the local network. This is where switches come in. A switch connects devices inside the same local network, often called a LAN or local area network. Think of a switch as the local traffic director. If your laptop needs to send data to a printer in the same classroom, the switch helps that traffic get to the right place without sending it out to the entire internet. More precisely, a switch learns which device MAC addresses are reachable through which ports. We will go deeper on MAC addresses later. For now, remember the beginner version. Switches organize local network traffic. Spot the mistake. Laptop to classroom printer. Should this traffic go to the internet first? No. If both devices are in the same local network, the switch can handle that local path. A router has a different job. A router connects different networks. If a switch is great at moving traffic inside one local network, a router is the device that helps traffic move between networks. For example, your school library network is one network. The internet is many, many other networks. If your laptop wants a video server outside the school network, the traffic needs a way out. That way out is usually the router, also called the default gateway for your device. Default gateway sounds fancy, but the idea is simple. If your device does not know how to reach a destination directly, it sends the traffic to the gateway and says, basically, you probably know where this should go next. Pause and predict. Your laptop wants YouTube.com, switch or router for the next big decision. Router. The switch may help the packet reach the router, but the router handles the jump between networks. Now let's add security. A firewall enforces rules about what traffic is allowed and what traffic should be blocked. For normal web browsing, the firewall may allow your request out and allow the response back in. But if a random device on the internet tries to connect into a private school file server, the firewall might block it. That is the basic idea. Firewalls help control access. Which traffic should a school probably block? A student opening a class website or a random outside device trying to connect into a private file server? The unknown outside connection should be blocked. One quick reality check. Sometimes a firewall is a separate device. Sometimes firewall features are built into a router or another security appliance. The job matters more than the box shape. Next up, wireless access points. A wireless access point, or AP, lets wireless devices join the network. Your phone does not plug into a switch with a cable. It talks over radio waves to an access point. Then that access point connects back into the wired network, usually through a switch. This is where home networks can make things confusing. At home, people often call one box the router, but that one box might be doing several jobs at once. It may route traffic, switch local wired traffic, apply firewall rules, and provide Wi-Fi. One box, several roles. Two quick CCNA bonus terms fit here too. A controller is a system that can manage or coordinate network devices. In wireless networks, for example, a wireless LAN controller can manage access points. PoE means power over Ethernet. It lets an Ethernet cable carry both data and electrical power, which is why access points, IP phones, and security cameras do not always need a separate power cable. Quick check. What device lets your phone join the network wirelessly? The wireless access point. Now let's put the whole trip together. You click play on a study video. Step 1. Your laptop creates a request. The laptop is the client. Step 2. Because the laptop is using Wi-Fi, the request goes to the wireless access point. Step 3. The access point connects into the wired network, where a switch helps move traffic locally. Step 4. The destination is not inside the school network, so the traffic goes to the router, the default gateway. Step 5. Firewall rules may check whether this traffic is allowed. Step 6. The router forwards the traffic toward the internet. Step 7. The server receives the request and sends data back. Then the return traffic comes back through the network, back through the router and firewall, through the switch, through the access point, and finally to your laptop. Pause challenge. Draw this path from memory before the answer stays on screen. If you got the order mostly right, you are already thinking like a network engineer. Before the quiz, let's clear up 3 common confusions. Switch versus router. Switches connect devices inside a local network. Routers connect different networks. Router versus firewall. A router forwards traffic between networks. A firewall decides whether traffic should be allowed or blocked. Sometimes those jobs happen on the same device. Router versus access point. A router connects networks. An access point connects wireless devices to a network. Again, a home box may combine both jobs, which is why the words get mixed up. The trick is simple: job first, box shape second. Here is the recap. Clients ask for services. Servers provide services. Switches connect local devices. Routers connect different networks. Firewalls enforce traffic rules. Wireless access points let wireless devices join the network. Controllers can manage network devices, and PO can power devices over Ethernet. If you remember only one thing from this video, remember this. Networking devices have jobs. Once you know the job, the diagram gets much less scary. Mini quiz. Pause after each question if you want to test yourself. Question 1. Which device connects devices inside the same LAN? Answer: a switch. Question 2. Which device usually helps traffic leave the local network? Answer: a router, often acting as the default gateway. Question 3. What does a firewall do? Answer: it allows or blocks traffic based on rules. Question 4. What device lets a phone join the network wirelessly? Answer: a wireless access point. Question 5. What does PO stand for? Answer: power over Ethernet. Question 6. Why can the phrase home router be confusing? Answer: because one home box often combines router, switch, firewall, and wireless access point roles. For practice, draw a tiny network with a phone, laptop, access point, switch, router, firewall, internet cloud, and server. Then trace the path from the phone to the server. In the next video, we will arrange these devices into network topologies, which is where the shape of the network starts affecting cost, reliability, and performance.